Welcome back to episode 2 of our explainer series on U.S. patent number 12664-142. If you caught the first part, you know we're looking at a truly groundbreaking piece of software architecture called the hierarchical script database. But today, we're shifting gears. We're zooming in on the totally fascinating, highly multidisciplinary journey of its inventor, Kyle McLean Smith. We're going to see exactly how a deep understanding of entirely different fields actually fueled a major technical breakthrough. Now, I have to ask you, what on earth does a hit country song have to do with complex database architecture? I know, it sounds like the setup to a joke, but to really understand this specific software patent, we first have to solve the mystery of how a musician and a copyright lawyer ended up reinventing data storage. Because it turns out the architecture of this database wasn't born in some traditional computer science lab. It was actually born on Music Row and Bay Street.
Section 1. An unconventional foundation.
This is definitely not your standard Silicon Valley origin story. Smith started out by graduating in 2006 with a degree in music business from Belmont University. From there, he moved up to Bay Street and Toronto to work in music publishing at Ole Media Management, which is now Anthem Entertainment. After that, he headed to Western Law School in Ontario and even did an externship out in LA to specialize in musical entertainment law. It wasn't until the late 2010s, after this entire journey through the music and legal industries, that he conceptualized the hierarchical script database and launched his programming business, SeedTreeDB.
It's just an incredible contrast, isn't it? Picture a guy who used to play guitar and mandolin in country bands, who even competed in Belmont's Country Music Showcase, eventually filing highly technical, non-provisional software patents with the United States Patent and Trademark Office. I mean, he worked with Kehrquist Sparkman, a firm whose clients include tech giants like Microsoft and Amazon, to secure this thing. But how exactly did he make that leap? Section 2. The music of data. Well, while he was deep into the weeds of musical rights and copyright management, Smith had this profound realization. He saw that music licensing agreements are, at their core, fundamentally structured hierarchies. Think about it for a second. A song has a writer, a publisher, performers, and distributors, right? And they all have these contract-based royalty schemas that manage relational dependencies over time. A percentage goes here, a flat fee goes there, all depending on exactly how and when that song is played. Smith realized that this intricate legal and musical structure is exactly what complex database schemas do. They manage intricate, hierarchical relationships over time. Take the event handler Vertex from his patent, for example. He built SeedTreeDB to handle data events dynamically. By using mathematical formulas, literally drawing on the golden ratio and Fibonacci sequences for data coordinates, he built a system that effectively treats code as a dynamic, creative asset, exactly like a musical composition. So code isn't just a static set of instructions anymore. It's a living, evolving structure. To explain this hybrid invention, Smith uses an absolutely brilliant analogy. In computer science, there's always been this fundamental division. Traditional databases use query languages optimized for data, which Smith compares to nouns. On the flip side, general-purpose applications use programming languages optimized for instructions, which he calls verbs. His architecture uses JavaScript as a single, homogeneous language, and it finally puts the nouns and the verbs right next to each other to form complete sentences and paragraphs all within a single runtime kernel. The crucial point here is captured perfectly in his own words. He actually said, "I don't think I would have had the written language skills to think up a database/program hybrid. I had to apply law and music techniques to make the invention." His technical breakthrough wasn't in spite of his non-traditional background. It was literally only possible because of his unique combination of legal, musical, and mathematical expertise. Section 3. The Good Shepherd Strategy. Now, getting a software patent today is notoriously brutal. As our sources point out, ever since the 2014 Supreme Court decision in Alice Corp versus CLS Bank, there's been this super strict framework that frequently invalidates software patents by just categorizing them as abstract ideas. To survive that kind of rigorous scrutiny, an inventor has to prove incredibly specific technical improvements to computer functionality. It's a really hostile environment. So why go through all that trouble and expense to patent something if your ultimate goal is just to make it open source? The answer is that Smith didn't file this massive post-Alice patent to lock his software away in some proprietary vault. Instead, he leaned heavily on his IP law background. He patented it to act as a good shepherd for the code as it transitioned into the open source market.
He wanted a rock-solid legal framework to protect the invention, so it could actually mature into a prosperous, robust community, with derivations built by others that go far beyond his own abilities. You can compare his strategy directly to the music industry. In music, a songwriter creates a track, and through publishers and royalties, they get paid even while the consumer gets to listen to that song on the radio totally for free. Smith's Good Shepherd patent creates a parallel framework for software. The code author creates the software, and the patent enforces structured attribution and royalties. This allows developers to monetize their creations while ensuring the end consumer still gets free usage of the open source software.
Section 4. A blueprint for open source.
Ultimately, he is actively investing his time in an ecosystem where open-source software authors are respected and compensated in the exact same manner as songwriters and music publishers. He makes the point that the music industry figured out a way to keep radio airplay free for consumption while still getting the creators paid, and he strongly believes the software industry can do the exact same thing for open-source code. There's a quote right on his GitHub sponsor profile that perfectly blends his programming mindset with his overarching business goal for the open source community. It's formatted literally like a line of code, and it reads, author, opt-in for revenue, consumer, zero cost. He wants to not only monetize the open source software he authors, but to empower other developers to do the exact same thing with their own hard work. Which leaves us with this final, incredibly provocative thought. Will the future of open-source software be saved by the royalty rules of rock and roll? It is a truly fascinating intersection of disciplines. By looking at music business contracts and copyright law, Kyle McLean Smith didn't just invent a new way for computers to store and execute data, he might have just mapped out the ultimate blueprint for modern software compensation, a blueprint that was hiding in the music industry all along. Thanks for joining me for this explainer. It really goes to show that sometimes the most revolutionary technical solutions come from looking entirely outside of technology.